Hello and welcome to our second lecture. And as you know from our first lecture, this class is about learning how to use modeling techniques in the 3ds Max to design and develop three-dimensional graphics and artistic features. So this week we continue basically our basic understanding of 3ds Max, and we just try to get a just simple hands-on experience with various topics in the 3ds Max Studio. And along the way, I'll have everything that we do basically set up on slides so that you could refer to them later on when you're working over this lecture if you wish. And for every single step I'll have also kind of tutorials that will show you where these things are and how the things work in the 3ds Max Studio. So it's kind of back and forth between the lecture and the tutorials, and this way essentially my hope is that it won't be just one single stream of video with lots of information in it, rather having every step also taken out and highlighted in slides. So we'll see how it works. And the objectives for today are essentially to learn how to set up your computer to run the 3ds Max Studio efficiently. In this case, I'll talk about how we can essentially customize graphics drivers if it has not been customized yet. Then we'll learn about how the 3ds Max interface looks like and how we can work with the user interface in the 3ds Max Studio. And then we learn about the basic modeling techniques. I'll show you simple stuff that we could do: create objects, manipulate them and modify them, save them in a 3ds Max scene, and then we'll learn the very basics of materials and how we can apply materials to an object. Then we'll learn about very basics of animation, how we can animate an object. Basically it's a rigid animation. We make use of very simple animation techniques, and how we can render the animations in 3ds Max Studio. So these are basically major functions in 3ds Max, and we learn about them in a very general way. And in the later subsequent classes and lectures and tutorials, we'll learn more about advanced tools and techniques and advanced features in each of these paradigms. So basically today's lecture will be essentially a brief overview of all the aspects that you have in the 3ds Max Studio, but then in each of the later lectures and tutorials we basically delve a lot more into the details and the advanced features of this that particular aspect. So so essentially, if you think of the more important parts of this lecture, the last 4 topics that I showed here, we will study them more in depth in the later chapters. 3ds Max Studio is a very big program, and it is very complicated and very computationally extensive, and therefore to get the best out of this application you'd have to modify and make sure that you adhere to the basic minimum requirements of the system, and also make sure that you actually exceed these requirements for your system. And then you'd want to modify and configure your operating system, your processor, and your graphic drivers to make the better use of these tools. So the first and foremost component of your computer is your processor, and for the best results you need to have a processor that runs more than 1 gigahertz, or essentially its speed is more than 1 gigahertz. And of course, the more speed you have, the faster your CPU is, and therefore the faster it handles the building blocks and components of your programs, including the 3ds Max. You need to have at least 1 gigabytes of RAM, or random access memory, in your computer. If you have more, it's better, because it takes some of the burden of memory off your your main memory and essentially runs more effectively. If your program is slow, perhaps the first thing that you might want to add to your system at the least amount of cost is an increased amount of RAM. You can actually, instead of changing your graphic cards, maybe adding some RAM might help a little better. One thing that you need to remember is that if you don't have enough RAM, that is, if you have less than 1 GB of memory, or if you have more than 1 GB of memory, but you have lots of programs and other software that basically clutter your memory, then you might your 3ds Max might run out of memory, and in that it starts swapping the memory and essentially uses the virtual memory, which is basically a part of hard drive that your computer would take as a virtual memory. And because your hard drive is a lot slower than your RAM, then your program gets stuck into this endless process of getting back and forth from the virtual memory to the main memory, and this way your program either crashes or just becomes very, very slow. So try to add memory if something like that happens to your system. Another thing that you could do is that there are several other programs that might be running. Some programs are resident agents and resident programs in your computer, such as instant messaging programs or programs like Real Player and things that are essentially handling your printer and other devices. Now, make sure that if you're short on memory, you shut these programs down or you disable them, and this way you release a little bit more memory. You could also go to your Windows Task Manager and see which program is not an essential system program that you need to have it running, such as a virus protection agent, and also which one is consuming the most amount of memory, and just shut them down. That's also another way to enhance your performance. The next step is to use the 3ds Max graphics drivers and essentially customize your graphics drivers to suit best the needs of your 3D application, which in this case is 3ds Max. Now, that customization comes with both your system option of your computer and the graphic cards, or you can use the 3ds Max essentially to set up the customization, and I'll show you how you can do that. Now, before we go to the 3ds Max layout, let me just show you how this customization can be done. So if you go to your 3ds Max, which I will go now, here I have started the 3ds Max 2011. You can see on top here, and on the main menu, which I'll discuss about it a little bit later throughout this class, you see the customize option. You click on the customize, and then you click on the preferences. In the preferences, you have a whole bunch of options, and the option that lets you customize your graphics driver is called viewports. And at the bottom of the viewport, you see the display driver. And the display driver, you can either choose the driver. I'm currently using it because it's installed, and then you can configure the driver. Now, my driver is ATI Radeon, and it's basically a Direct3D 9.0. So if I click on choose driver, if you haven't done that, you will have several options. Now I have a Direct3D version, which is 9.0, and so on and so forth. And of course, I'm hardware accelerated, so I'm using that. If you have a more advanced graphics driver, you could revert from 3D and then choose an OpenGL driver. And once you do that, it lets you. It tells you that essentially the next time that you run your your 3ds Max, it will take effect. So let me cancel this process here. All right. Now that we made sure that our 3ds Max Studio is configured and ready to go, you can essentially go to the view and the layout of your driver, your 3ds Max Studio, and see how it looks like. Before we talk about that, let's first discuss a little bit about the user interface settings, and then I'll show you all about the layouts and all the different menus and toolbars and windows and other options that you have that you could use, and panels and things like that, and what are the essential components of each of these components of your 3ds Max. This would be a great thing to start getting ourselves familiarized with this this environment, because it is a very highly customizable environment, and there are many different things in it. And to learn about this and know where things are earlier in the game, we get a lot better chances about improving our speed and efficiency when later on we are working with more advanced stuff. One of the most important things that I want to discuss is about the user interface in your 3ds Max, and that I would like everybody to use the default user interface. And I'll show you how you can make your user interface default. The reason for this is that 3ds Max is a very highly customizable UI or user interface, and it allows you to set up your workspace the way that you feel the most comfortable with it. The problem with it is that when you're learning this program, especially in a course in which multiple students from multiple different backgrounds and favorite programs and software packages are working, we need to adhere to some sort of a standard, and that everybody would be looking at the same thing when they are working with their individual program, especially when you are following the tutorials or different things in books that are written for as a learning tool for those applications. And so for this reason, I will perform everything in the videos that I'll have accompanying this class in the default view, and I'd like everybody to learn how to make their default view or the layout as a default layout for your 3ds Max. So here I'm going to show you how you can do this in the environment. So here it is the default view, and everything is basically set up back into the factory setting. Now, if your view doesn't look like this, or if you would like to make sure that it actually is in default, if you're not sure, you could use the customize function and then or option from the main menu, and then you will see the customized user interface. That's what I was talking about, that you could make your user interface customizable. You could revert to startup layout, or you could load your custom UI scheme. If you click on custom UI scheme, you can load a custom UI, which is a default UI, essentially default UI.ui. And you click on it, and then you click on open. It will open your default scheme. Because I'm in default scheme, I won't do this. And the thing is, when you do that, then the next time you restart your 3ds Max, the default scheme would kick in. Okay. Now, if for some reason you are not in essentially the default scheme, or you don't have the access to the default scheme, click on My Computer, and then go to your program files wherever you have installed the Autodesk and 3ds Max. Then click on 3ds Max 11, and then go all the way down to UI folder, and then you can click on the default UI.ui and then open. And in this sense, your customized setting will basically load its scheme from default scheme. Once you do that, you can click on customize, and then you can lock your layout. So go on to customize and lock the layout. This way your layout will be changed, and you can't by mistake move things around and change the look of your user interface. Alright, now the next step is to learn about what we have in terms of the menus and different options that we can choose from the layout to work on different things. Basically, like every Windows program, your 3ds Max program has a menu across the top, which is called the main menu. And this main menu contains lots of items that you can essentially use for many different purposes, from saving a file, loading a file, customizing your layout that I already showed you how to do at, launching panels, and all the different sorts of things. And for example, an example of this item is help, which you can either go on the main menu at the far right and click on help, or you could basically press F1. There are a couple of topics, important windows that you can use and actually are offered by 3ds Max. There are floaters and dialogues, and there is a little bit of a difference between the two, and I just would like to mention them because the book discusses these things. When you select certain items on the main menu, a pop-up window may appear that is basically a rectangular object, and it's basically contains several options that you can interact with the program, and this is called a dialog box, or simply a dialog. For example, if you click on Customize and then you go on Unit Setup, which I will show you a little later, a dialog opens and it lets you work with different things. Some of these dialogs are models, which means that what is displayed, when the dialog is displayed, you cannot click on any other place on the window. And some other dialogues are model-less. Floaters are a special type of dialog which are mode-less, and that is, when you have this dialog box on top, you can move it around, and at the same time, while the dialog box is open, you can click on several other parts of the screen and interact with the screen. So let me show you how the main menu looks like, what different options we have in the main menu, and what is the difference between the modal dialogues and modeless floaters. Okay, here we are on the main screen, and across the top you see the main menu. Which is essentially on top you have several already selected options from the main menu that are more frequently used, such as new project, or new scene, load file, open file, save file, undo, and redo. And then you have other menu options like edit, tools, group, view, create, modifier, and all the different tools that you could use. So for example, and you know, like Microsoft Products 2007 and 10, there is a 3ds Max button that has predefined frequently used items in it. So but for example, if you go to the Customize and then Unit Setup, a dialog will open, and if you click anywhere else on the screen, a beep with basically sound, and that means that while this option is on, you cannot interact with any other part of the screen. And it has dialog options that you can choose. For example, from the display unit, you can choose metric or other display units, or you can have standard US, or you can have customized US. So here you have the generic units set up for you, and lighting units, for example, is international. You can have American, and so on and so forth. We'll talk about them a little later when we are actually discussing the details of these options. An example of a floater basically is when you click on Tools and then you click on Display Option, or Display Floater. When this Display Floater is open, you can move it around pretty much like a dialog box, but you can also interact with other parts of the screen. So for example, you can create, for example, a sphere right here in the screen while you're basically working. And when you're done, you can just simply close the floater. Okay, another option of tools that you have in the 3ds Max is basically the main toolbar. And I'll go over this main toolbar on the interface again, but a couple of things that are important are essentially the flyouts those are the icons or items on the main toolbar that have more than one function, and so they're basically stacked on top of each other, and you see only one icon and those icons usually have a small little triangle or a little line at the right lower right corner of their icon on the toolbar, and in order to get access to other functions within that group of icons or functionalities, you click your mouse on top of it, on top of the little small triangle at the lower right corner, and then drag it down. Hold it. When the flyout opens, then you can drag your mouse while holding your left button down, and I'll show you how to work with that. And that way you'll essentially be able to choose several functions. There's another set of icons on the toolbar that I will talk about. They're called snap controls, and the snap controls essentially allow you to move your object or rotate them and work with your geometry more precisely, and I'll show you how these things work. So let's go back to the environment, and I'll talk about the main toolbar in the environment. So on top you will see the main toolbar, and you have several options. Again, as I showed you in 2011 version, the undo, redo, and save, and all the other kinds of frequently used tools have been placed on top of the environment, but the main toolbar is the one that's right underneath the main menu. You have several options here. You could for example, select an object. You could select objects by name. So here I don't have any objects, so the name is empty. You could essentially link objects. You could unlink objects. You could bind objects to space warp. There is the rectangular selection region, and as you see at the bottom of this lower right corner of this icon, I have a little triangle here, a little line here. If I hold my mouse, the flyout opens, and then while holding the left mouse button down, I can move around and select different options. This is the window or crossing section selection. So if I mean the window selection, when I drag my mouse over, I can select everything that's within the window or in the crossing section. Then there's the object manipulators. You can click and select and move objects, select and rotate objects, and uniform scale, of course. And then the snap toggles I showed you are the ones that are in the middle section here. So again, this snap toggle has three options: 2, 2.5, and 3. Basically is the step of the snap. You can toggle the angle snap when you're rotating your object, percentage snap, and so on. So as we move on, we'll learn more about how these work out. In order to customize your snap properties or snap settings, you can click on Tools, and then you can click on Grids and Snaps, and then click on Grid and Snap Settings. And then you click on Grid and Snap Settings, several options appear. You can have standard snaps, you can have body snaps, you can have NURBS snaps, and we'll talk about some of these as we move on more in detail. Then options, home grid, and user grid. And so these are the options that you have to work with your environment here. Some functions in 3ds Max software are basically in themselves independent programs. That is, they basically work with a set of properties and a set of topics and tools within your 3D graphics that are not particularly related to the any part of your application, but rather they are in themselves. They are complete applications themselves. So these are additional interfaces that basically are written within huge subprograms or huge programs. Previously, in 3D application settings, the 3D applications would be dealing with the modeling, and then you'd have another application that you would create materials and things in it, and you'd have another application to deal with graphics and animations, and so on and so forth. So in 3ds Max, basically everything has been modularized and embedded and incorporated within your 3ds Max software within different modules. And these are essentially independent editors. Here are several editors that I listed here, from material editors to RAM player, and I'll just tell you in brief how these things work and what they are essentially. And as we go on in the class, we'll work with these throughout the course more in depth. So basically, if you think of an editor, it's a panel in 3ds Max that is a large modeless dialog. Basically, it's like a floater, and they are very powerful, and they have special features and special tools and techniques that help developing a unified three-dimensional application. There's the material editor. It's basically the interface and the material that is used for designing surface materials. You could create different kinds of conditions for materials. You can give the shininess and all the properties that materials have. There's the edit UVWs. This is for placing maps on three-dimensional objects. You import textures, you create materials, you apply them on texture maps, and then you apply them on the surface of your materials. There's the dope sheet, that's the editor for managing animation keyframes. Curve editor is an editor for editing animation curve data, in the sense that, for example, you have two keyframes and then you want the interpolation of the animation in between frames to be linear or follow a specific kind of curve. You can use the curve editor to do that. The schematic view is for viewing and manipulating object and scene relationships. Environment and effects are used for creating special effects such as sparks and kind of particle effects and things like that. The render scene editor is used for choosing render output options, and finally RAM player is for viewing rendered images, image sequences that you created in an animation. All right, so another interesting tool that you have in the 3ds Max Studio is basically called quad menus. The quad menus are context-sensitive menus and options that you can access by right-clicking an object in the viewport. These quad menus are context-sensitive. That means that they will be different depending on the situation. You can customize basically these quad menus and their shortcuts, and essentially there are some of these customizations pre-made. For example, if you hold down Shift, Control, or Alt while right-clicking on the object, different quad menus will show up. For example, for modeling or animation and things of that nature. Let me show you how this works real quick. So here I have already created an object, and if I left click on it, it just won't be highlighted. But if I right click on it, a quad menu appears, and it tells me that what I can do with it: move it, rotate it, scale it, and all the different sorts of options that I could select from the menus and the toolbars. But here they are basically shortcuts that are created for me. Now if I left click somewhere else, it will be unselected and the quad menu disappears. If I hold the control and I right click on the object, you see a specific option or menu will appear. If I click on Alt and right click on the box, a different quad menu will appear, and I'll have different options now. This, for example, holding Alt and right clicking brings up options from the animation tools, so I can set keyframe, I can show trajectories, toggles, and stuff like that. If I hold on Shift and right click, a different quad menu appears that basically allows me work with the snap options of this object. So and just simply right clicking on it, a different set of quad menus will appear. At the bottom of your 3ds Max interface, you'll see an area that's called the status bar area, and I'll talk about this area in a little detail, and I'll show you on the script on the 3ds Max how it looks like. But let me just give you a couple of quick hints about what these subdivisions of this status area bar are. To the left part, to the far lower left corner of the interface, you will see 2 empty fields, and these are called the Max script and mini listener tools, and these are text command options in 3ds Max that you could type in commands from the 3ds Max's scripting language called Max script. You can program 3-dimensional objects, and you can do lots of different things with the 3ds Max. We won't go into the detail of scripting in the 3ds Max Studio. Maybe in a more advanced topic we will you can study it because it requires some sort of programming skill. Next to the Max script mini listener area, you have status line and prompt line, and these are basically the 2 text areas or text boxes that give you information about the current action or command that you are taking in the 3ds Max Studio. If your screen resolution is low, you might need to scroll down and find it, but if your screen resolution is more than 1280 pixels, you can see all these texts. The top text field is basically your status line, and it tells you what objects you are currently working with and stuff like that. And the bottom line is a prompt line, and it tells you what you need to do next to complete an operation. So if you don't know what to do, the first place to look at in the prompt is the prompt line. It doesn't lead you through every single step of creating the 3D-dimensional graphics, but it will give you a good feedback, especially if you're just beginning to work with this program. The transform type-ins are interesting things. When you select an object to move or to rotate or to scale it from the main toolbar that I just showed you in the previous slides, a number will be appear in the X, Y, and Z fields of the status bar, and these are basically called transform type-ins. The reason that they're called transform type-ins is that X, Y, and Z values of each object is essentially related to its location, orientation, or rotation, and scale, and these are basically called transformations in computer graphics, and that's why these values are called transforms, and the transform types in are where you can type your transforms. So what you can do, for example, you can select an object to move, and you can manipulate its location, rotation, or orientation by typing in these values in transform type-ins, and we'll discuss these type-ins a lot more thoroughly in the later classes. Next options are the animation controls options, and those are basically the section of the status bar that help you deal with an animation. You can basically create keyframes manually or automatically using these options. You can choose which object you want to animate and what type of keyframes you want to create, and for example, if you want a location or position keyframe that basically moves objects, or a rotation keyframe basically to rotate your objects. Next to the animation controls is time controls. They're basically like the time controls on a CD player that allow you to pause, fast forward, slow forward, play, stop, and this kind of things that you could do with your animations. The time configuration button that I will show you in the application in the 3ds Max is basically a button that launches a dialog that you can control the frame rate, display speed, and the number of frames in an animation. So I'll show you those in a little more detail. Next to it is a track bar. The track bar is basically labeled with the number that represents the current frames in an animation, and it would essentially show you in which part of the timeline of the animation your current frame is, and also it displays keyframes for a selected object. There's a time slider above the timeline, which you can move around through time and to see how your animation would play in the viewport, or you can locate a specific frame in time of your animation. It also shows you the current frame and the number of total frames in the current animation segment. So let's just go ahead and check these things out in the application. So let's start with the far left corner, and in here you'll see you have the Max script and mini listener object. And for example, if you type in teapot radius 50, a teapot with a radius of 50 will be created, and the mini listener essentially tells you what happened. And so let's delete this and let's make a sphere radius 1. Okay, so I have created a teapot and a sphere at the center of the screen, and then I can move them. So you can type in a another teapot radius 3, and a bigger teapot will be created. So this is essentially the scripting language for your 3ds Max. Anyway, so next to it is basically your down here you have the status line and the prompt line. So the status line right now tells me that nothing is selected, and click and drag to select an object. If I click on this teapot here, it says one object selected, and the prompt line tells me to click and drag to select and move the object. So I could move the object. And now if I had clicked on the scale and I click on the object, it says that click and drag the selected object to rotate the object now. So I can use this information that the prompt line tells me. Of course, these are very limited commands and things like that. Next, you will see the XYZ transform type-ins, and notice that here the object is selected and it's in rotation mode, and it says that the rotation is 0 degrees along X, 0 degrees along Z, and 31.45 along the Y direction. So if I type in like 67 degrees, it would change the, as you can see, the rotation of this object. And you can also use the transform, for example, while you're clicking here, and it tells you it's located at X15, Y minus 8.5, and Z at 0. So if you want to move it 10 points along the Z direction, you can type in 10 on the Z transform type in, and it would change your time. You have also the grid that's also selected at 10, and essentially it tells you what is your grid setting. You can change that grid setting also. Next, you have the animation controls. You can select a key, you can add a key, you can set keys, and you can basically create different kinds of things. And you have also the default in-out tangents for new keys. And so essentially these are animation things that we'll work out with them a little bit later. Next options are your time animation. So you have the play animation, you have the previous frame, next frame, go to end, and go to the start, and underneath you have the time control configuration down here. And of course, next to the time control are the icons that you can work with on with the viewports essentially. Okay, one last section of the tools that you have in the layout of your application is basically the command panels. At the right side of the screen in the area, you see an area that has several tools and windows, and it is basically where your commands are. It's called the commands panel. Tools in this command panel are used for many different purposes, and you can create objects, you can modify objects, you can control animations, and a lot of other things. and miscellaneous utilities. There are, at the top of this area, there are 6 tabs, and I'll show you in the application in 3ds Max, and these are the tabs that allow you to create objects, modify objects. You have the hierarchy tab, motion tab, display tab, and utilities tab. So when you move your mouse over these tabs, a tooltip appears and tells you what they are. The leftmost one is the create, and then goes on modify, hierarchy, and so on and so forth, and I'll tell you on the 3ds Max what these things are. The items within each of these panels are organized into rollouts, which you can actually look at them and maximize them, and essentially they are minimized, some of them, to give room for other items, and you can maximize all of them or minimize them. The panels are scrolled vertically, and you can go all up and down to access different options within that particular rollout. And there's a scroll bar that you can do that, or you can scroll up and down with the middle mouse click. Okay. The command panel also can be expanded horizontally if you need more information about your rollouts. You can basically undock them. They're automatically, by default, are docked into the right hand side of the screen. You can undock them and make them floating around the screen and move them around by basically using the customization options. So the create panel essentially is used to create objects, and you can click on the create panel and click on the different buttons to choose the geometry of the objects that you are creating, and you can click on different options, and I'll show you the options that you have. There are parameters that you can use. For example, making a sphere, you need to create a radius, and you can change radius parameters of the object. If you are using an arc or a cylinder or a tube, you may have different parameters like length, width, height, and number of segments and things like that that you can work with. There are also spinners that you can change the parameters with these spinners. Essentially, there are 2 little arrows that I'll show you. You can increase or decrease the length or width of an object. And when you create an object, the parameters on the panel are used to set the object's dimension. These dimensions are expressed in units. A unit can be represented basically to be 1 inch or 6 meters or 3 miles long, and is essentially the measurement that you basically wish to use. Units are important because when scene needs to be made to architectural or engineering specifications, and when the scenes will be shared with other users in the project, the discrepancies might occur if people are using different kinds of units. And I showed you how you can change the units. You can go to the tools, and then you can go to the units setup and change the units options that you have. The next panel is modify panel. The modify panel is a panel that you can use to change the parameters of your objects. At the top of the modify panel, there is an area called modifier stack. This area allows you to add functions and effects called modifiers of the geometry, and we will study them a little bit later in the class. So let me show you all of these objects that I talked about in the 3ds Max itself. Okay, to the right you'll see the control panels, and by default we're on the create, and if you click on the create you will see that you have geometry that's by default selected. You can have shape selected, you can have lights, you can have cameras, helpers, and so forth. So in geometry you have a select box or list box that you can select standard primitives. You can have extended primitives, so you see that things are a little bit now different. For example, you can have an oil tank created, and this would modify the shape of the oil tank, and other types of objects that you will see. So let's click on the standard primitives. Then with each of these primitives, you will see that you have various options that you can choose from. For example, having it create by center or by edge. You can have keyboard entries for this object, make the X and Y and Z and radius of this object. You can select different parameters for the object and work with them, and we'll see these in the modeling topics. We can click on the, for example, modifier, and you see on top you have the modifier list, and in the modifier list you can add and choose several different kinds of modifiers to modify this object, and we'll work with them a little bit later in this class. So we can select mesh, and you can, as you see, there are quite a few different kinds of tools that you could use. And as you go on, you will have other different control panels that you can work with, and we will see them, the majority of them, in this class. There is a good deal of discussion and talk about viewports and coordinates that I would not go into the detail because I would like to start working and showing you how to do things in 3ds Max, and I'll leave it to you to study pages 31 to 43 of the textbook Harnessing 3ds Max 8, and there it will tell you about the theory and the background behind different types of viewing mechanisms, perspective viewing and orthographic viewing or axonometric viewing, and you can see a little bit about the detail about those kind of things, and it'll tell you how to work with the display options that I showed you in the last week lecture, how to navigate through viewports, how to move around viewports, maximize a viewport, and things like that. And also there's a good discussion about the coordinates and basically what they are: three-dimensional coordinates, two-dimensional coordinates, global coordinates or world coordinates, and object coordinates, and things like that. And we will use those kinds of information later on, essentially, I would say kind of unconsciously, when we are working with the objects. So our next step is to start talking about how we can work with the basic modeling, essentially. I'll have showed you a few of the topics about these create control panel and the pull down menu that shows you where the standard primitives are and what other kinds of primitives you have and how you can create these objects. And I'll talk a little bit more about both creation of the objects and modification of the objects, essentially applying a modifier. And the process that we will do is that we create an object and we apply several modifiers on it. We bend it and we twist it and stuff like that. And that would be our first basic modeling. And then we move on to transforms and other kinds of applications and modifications and manipulations that we could use and we could apply on the three-dimensional geometries that we make. Alright, now that we have talked about the basics of the 3ds Max so far, let us consider the basics of three-dimensional modeling. There are many different ways that you can model an object in 3ds Max. And all of these object creation methods can be available from the Create panel or the Create tab on the right hand side of the default 3ds Max view. And I'll show you about all of these topics that I'll discuss right now, and I'll show you how these are essentially done and used in the 3ds Max environment. When you click on the Create tab, basically the first button that's called Geometry will be on, and you can click on the geometry, and then you will have a pull down menu which will contain the words standard primitives. Standard primitives are essentially the objects, the basic objects that 3ds Max would allow you to create in the construction plane. The pull-down menu contains several other options, extended primitives and other options that are and primitives that I just briefly showed you earlier, and they contain three-dimensional geometry of the objects that you can automatically start building in your three-dimensional environment, and then you can manipulate and modify them, as we'll see a little bit later today, to create more complicated and complex three-dimensional scenes and objects. So again, what a primitive is the basic standard building block of a three-dimensional scene. Each of these primitives will have their respective parameters, such as radius, length, height, and so on. And once you create them, you can manipulate these information and these properties of your objects. Two of important things in a primitive is the number of sides and segments that they have. Certain primitives, each primitive may have certain number of segments, which are divisions along or around the object. So if you're looking at a cylinder, it may have each segment of the cylinder is basically a solid disk that you stack them on top of each other and you create the cylinder. And each object may also have sides, and these sides are number of divisions and sections within each segment, which is at a right angle to the segments. And I'll show you these properties, sides and segments, in the environment. You may have the number of sides and segments set up to a particular default value, such as 0 or 16. You can increase and decrease the number of sides and segments, and these numbers would control the resolution of your object. So if you have an object with a larger number of sides and segments, its resolution would be finer, and the less the number of the sides and segments, the less resolution for your object. There's a quick thing to remember here, in that the number of segments is a critical modeling choice. If you have basically an object with lots of segments, then it may render it may become a little bit more complex for the rendering to mechanism to render the object, and not necessarily increase the resolution to basically the human's eyes. So sometimes when you increase the number of sides and segments after a certain value, then the visual resolution that you get, the difference, wouldn't be worth the amount of processing that you would impose on your GPU. When you create and manipulate objects in 3D, usually you work in two-dimensional spaces. Basically, you work within XY, XZ, or YZ, top, left, and front view of your objects, because your monitor is a two-dimensional space and it shows you two-dimensional information. And if you use or try to force a three-dimensional scene, you may not get enough accuracies visually to design a desirable scene. So most of the times you might work in 2 dimensions, and 3ds Max program also offers and enforces this kind of 2-dimensional conditions in the object creation. So if you're creating, for example, a cylinder, and you're looking from the top view, basically you're looking at the XY plane down at the Z axis, you can drag your mouse and create the base of your object, basically the circle. You can't not really enforce the Z axis and basically specify where on the Z axis your cylinder should appear. When the object is created in a viewport, usually it will be placed on a construction plane, which is designed by the grid lines running through a viewport. The default construction plane is the home grid, which is made of the world coordinate XY, XZ, and YZ planes. And the intersection of these three construction planes creates the origin of your world space. So if you design in the top viewport, the cylinder can be created so that it sits on the XY construction plane and the base of the cylinder to be at the coordinate of 0. Notice that you cannot move the home grid, and it's basically the world coordinate system here, and you can't really base home grid on other parts of the scene. However, you can create other kinds of grids. A very helpful feature that 3ds Max provides you is the ability to quickly and easily create objects on the surfaces of other objects. This is called the auto grid, and you can find it on the create panel right below the pull down menu, and I'll show you what it is. When you enable auto grid and you move your cursor over an existing object in your scene, you'll see that the axis tripod appears, and the z-axis of the tripod will always remain at the right angle with the surface of the existing object, so you can create objects on top of each other. So I will delete all these objects. And so if you look at the right hand side of this object, you'll see that there are several panels on top. Create and modify are the two leftmost ones, and when you click on the create at the bottom, you'll have several options, and the option of geometry is where you can do your modeling. The lights option would allow you to put the lightings in your scene. Cameras would set up cameras in your scene, and so forth. But we want to do basic modeling. Once you click on the basic modeling, you'll see standard primitives appear. And under the object type, you'll have the box, the sphere, cylinder, and so on that we saw earlier. And the auto grid is the option that you could click and create objects in other construction planes. So this is the construction plane, the home grid that I was talking about. And let's put other viewports on. And so we were in the perspective viewport, and I clicked at the bottom right corner of the screen where it says maximize viewport toggle, and now I resize my viewports by left clicking in the middle of the screen where all the viewports meet. The cursor changes shape, and then you can resize your viewport. So you have the top, left, front viewport, and the perspective viewport. Now if you wanted to create a cylinder in the top viewport, oops, this is a sphere. If you wanted to create a cylinder in the top viewport, you see that you only have access to the X and Y coordinates. This is the coordinate axis. Y is the vertical and X is the horizontal axis. So when I drag my object and left click and I create the base of the sphere, as you see here, it is essentially placed on the basically at the 0 or the base of the z-axis. So if I drag my mouse up, it would be placed basically above the xy plane. If I drag it down, it will be placed at the bottom of the xy plane, and you can see the effect in the perspective viewport. Okay, now let's create this object by left clicking one more time and setting the object. So here's how my my object looks like. Now zooming in on the left viewport, on the front viewport, and zooming out, I want to show you what the segments and sides are. Now if you look at this object, each of these horizontal portions or parts of this object is a segment. So let's click on the object, and when I highlight it, each of these lines that you see along the horizontal axis, this is a segment of the object. So this object has 1, 2, 3, 4, 5 segments. let's select it one more time. And the sides are basically the vertical ones. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2, about 20 some sides. You can control this the number of sides and segments by looking at essentially the properties or parameters of the object on the right hand side. So this object has 18 sides, so let's make this object with 2 sides essentially, or let's say 6 sides. And when you're creating this object, you see you will have 6-sided triangles, spheres. And of course when you're and the number of segments is already 5, and you could basically change the number of segments by making it 50, for example. And now when you're creating this object, you'll have a lot more segments. As you notice, the finer resolution along the height of the object, whereas with 5 you would have an object of the same height, but it would have a different number of resolutions. So the one to the left has 50 segments. The ones to the right have have 4 segments or 5 segments. And if I increase the number of sides, my cylinder would become a lot finer in terms of the number of sides that is an. Let's maximize this viewport. And so as you see, an object with too many sides will be finer resolution. Essentially it's going to be rounder, and the objects that have fewer sides in terms of like the cylinders, they'd be basic, they won't be basically cylinder looking. Okay, now suppose that you wanted to create a sphere. So if you click on the sphere and then you're in the 2-dimensional viewport, you'll see that your sphere will be placed on, again, on the cylinder viewport. But you could click on the auto grid, and then when you move your object, your mouse over, let's say, on the top viewport, and you're close to the surface of a cylinder, your viewport automatically clicks, or your grid construction plane automatically clicks on the surface of the object. And then when you create your object, it will be placed actually on the surface of this cylinder. Now let's go to the perspective viewport. And let's try to create a box on top of this sphere that's attached to the cylinder. Now if I click on the auto grid, and when I move my mouse actually outside of an object, the grid will be placed on the XY plane. When I'm close to the surface of this sphere, the sphere, as you see, look and carefully notice the way that the XYZ axis is moving around. Basically, my construction plane is now tangent to the surface of this sphere. And notice this Z-axis. Notice the Z-axis keeps always pointing just outside of the surface, perpendicular to the surface of the object. So when I left click, you see this will be my construction plane. Now notice the changes to the construction plane, or the auto grid, which is now perpendicular, actually tangent to the surface of the object. and when you create your box will be placed on the surface of this a plane, and then when you move your mouse up, now your object is created within on top of the sphere. And if you notice in the left viewport, let me get rid of the other objects. Your box is now essentially on top of the sphere. So you can move the viewport just to show you how it actually looks like. Okay, let's orbit the viewport a little bit. So the object is essentially located, as you see, on the surface. So, and the object is tangent to the surface of the sphere. Anyway, so this way you can create objects of this kind. Notice that each of the objects that you created here, they have been assigned a color, and each of them also have a name. So the object name will be based on the type of the object or the primitive, and also they would have an automatic number that tells you essentially it will automatically be assigned to them when you're creating them. So the pink sphere that I created, its color is pink and it has a name called sphere 001, and if I create another sphere somewhere else, it will be, and let's undo the auto grid, so they will have different colors, as you can see here, and so essentially and they would have different names: sphere 7, sphere 6, sphere 5, sphere 2. Now you could change these names essentially to meaningful names, and also you could change the color of these spheres by clicking on the color palette, and then the color selection tool opens up and you could choose and select different colors for your objects. And once you have assigned the colors, then you could click on OK. Of course you could add custom colors, basically make up the colors by RGB components, by hue saturation value components, or by hue and whiteness component. In the hue and whiteness you have a two-dimensional color component that you have here. You choose the color and then you move the whiteness of this color, and as you see it automatically changes the values. And then you click on add color, so you added the new color to the leftmost custom color palette. Then you could go on from the hue and whiteness, create an object, a new color, and add the color to the next custom design. Let's do an RGB, that would be R, that would be G, that would be B, and then let's do a hue saturation. Let's say I want a blue color, and I want it to be completely saturated, and I want its value to be high. So so you can create colors like this, and once you have the colors selected, then you click on OK, and your currently selected object color would change. So you could even move your objects, as you can see here, by moving the XYZ axis of the objects. And so this auto grid thing automatically allowed me to create an object on the surface of another object, but I haven't assigned and locked these two objects together, so I can move them, move the objects around independently. And I'll show you a little later today how you can do this automatically. Okay, so we created objects. Basically, we just went in the Create tab, clicked on Geometry, and then clicked on primitive, simple primitives or standard primitives, and we just literally made simple objects like spheres, cylinders, and things like that. Modifiers are functions that can be applied to an object primarily to change its shape. If you want to add a modifier to a selected object, you can go to the drop-down modifier list from the modifier menu, and then or modifier tab, and then you can basically choose the modifier from the list that of modifiers that is arranged in the alphabetical order, and then you can add and click and add the modifier to your object. And I'll show you in a little bit how that can be done. Notice that modifier list is context sensitive. When you select an object in 3ds Max, the software knows which kind of modifiers can be applied to it and which ones cannot be applied to it. Then the modifiers that are not possible for a currently selected object will not be displayed. So for example, the extrude modifier may not be available, is not available for a three-dimensional primitive because for a particular type of modifiers or objects in primitives, the extrude function does not work. You can also add and choose modifiers from the modifiers menu on the main menu of the software. And in this case, modifiers that cannot be applied to currently selected objects will be shown in a kind of gray washed-out color. When you add modifiers to your object, the modifiers will be added to the modifier stack, and you can apply multiple modifiers to an object, and they will be placed on a modifier stack, and they will be applied to your objects essentially in the order of operation from the bottom to the top. The modifiers that are at the bottom or are lower in the modifier stack, they will be applied first, and the ones that are on top, and they will be the ones that will be applied later on. So if you have two same objects and you apply multiple modifiers in different orders to them, the end result of this process will be different. So for example, if you have an object and you first bend it and then you taper it, or you first taper it and then you bend it, you'll see different kinds of results being shown to your to the final object. Another thing to notice is that the order of the modifier operations is not basically chronological. That is, that it doesn't matter how early or how late you apply your modifiers to the modifier stack, they still will be ordered and processed from the bottom to top. And you can order and reorder your modifiers. Basically, move the modifiers within the modifier stack up and down to get the desired result. You can even copy, paste, and cut and paste the modifiers within the same object or among different objects, and you can right-click on a modifier to access it, and then from the pop-up menu you can choose to cut, copy, paste, or perform other types of operations on your modifiers. And we'll see an example of that in a little bit. To access the parameters of a modifier, you can select it from the stack, and at the bottom panel under the modifier list or modifier stack, the properties would be displayed, and you can essentially see the end results of all of the modifiers at the same time. There is an icon which allows you to see the result of the modifiers applied up to the modifier that you select. Now notice that when you select a modifier, it doesn't matter which one you select. The result that you will see in the viewports is the result of all modifiers applied. Now if you want to see up to some modifier how the object looks like when you're debugging and modifying your objects, there is a button called Show End Result button, and if you uncheck that or click it, then when you select a modifier, the results that will be shown will be the results of the modifiers from the bottom of the stack up to the modifier that you have chosen. Each of the modifiers will have a little light bulb next to it, and you can click on it to disable or enable them. And so these are pretty much it, and I'll just want to show you how these modifiers actually work and how the modifier stack works inside the 3ds Max. So let's go to the 3ds Max. Okay, now I'd like to create a box and then apply modifiers to it to change it into an object that looks like a horn. And then along the way I'll talk about different types of modifiers, and also talk a little bit more about the specific type of modifiers that I'll be using for this particular object, and we'll see how the order of modifiers would make a difference. So first we want to create an object, a box object. So click on the create panel from the primitive objects, click on box, and in the box let's make the line segments length segments 1, and let's make the height segment 10, and then let's create a box that essentially will have 17 by 17 by 28 or 30. So let's make this 15 by 15 by 30. So this would be our object, and if you notice, the object is looking basically three-dimensional, and if you press F4, the perspective view also shows you a wireframe of the object, essentially shows you the faces. Now what I want to do is that I want to apply modifiers to this object. So click on the modifier panel, and then while you select box, the object you created, click on the modifiers list rollout or pull down menu, and you will see several types of modifiers. You'll have selection modifiers, which would basically apply the modifiers based on the selections that you have chosen: mesh select, patch select, poly select, and volume select. We'll see these things a little later. You'll have world space modifiers that are several types, and we'll discuss them later. And then you have object space modifiers, which would apply these modifications to the objects themselves. And as you can see, there are quite a few of the modifiers that you could apply and use on your objects. So the first modifier that I'll use is a bend modifier. Basically, it takes the object and it bends it. When you click on the bend modifier, the modifier is will be added on the modifier stack, which is this panel on top here, and it will be applied on the box. So your box will have a modifier that is bend, and it has two parameters. The angle parameter, I want to bend it by 90 degrees, and then I want it to be 90 degrees rotated, basically. So that would be the direction of the bend that you want it to be applied, which would be along the Y axis and with the 90 degrees. And this is how your bent object looks like. Now, because the object that I want to create is supposed to look like a horn, and horn has a kind of pointy, one pointy end and one larger base, I want to taper this object so that it would squeeze the end of the objects. So the modifier that I'll use is going to be a taper modifier, and the taper modifier, as you see, is on top of this stack. And on when I apply the taper modifier with the amount of, say, -1, so this is how my my object looks like with the tapered modifier with amount -1 applied on top of the bend modifier. So this doesn't look quite like the one that I expected, but if I rearrange the modifier and change the parameters, I'll get the desired effect that I wanted to see. So here's actually how my object is supposed to look like. Now notice, by changing the order of your modifiers, your objects would end result would look totally differently. And so this is an object where you first apply the bent modifier, mainly first you bend your object and then you try to taper the object. Whereas if you reorder the bend and taper, you first squeezed one ends of the object's vertices to merge with each other, or essentially get closer, creating a pointy shape, and then you apply the bending this object. Now, for this object to look more like a bullhorn, I'd bend the tapered object 90 more degrees, so it's 180 degrees, and as you see, it looks something like this. And I can change the length or the height of the object from (30) to 180 to 100 and what did I do, to 150, and therefore I actually changed my the appearance of my object by changing the object size, because these modifications are applied on that particular object size. When I change the size, these values would have to change. And for example, for the taper operation, I completely messed up the object. Now, to see how this object looks like up to some modification within the stack, I could click on this show the final results icon, and this will show me how my object looked like from the beginning all the way to the first taper operation. So you see this this taper is applied differently. So what I need to do is basically to play with this taper parameters and make sure that I will get the exact results that I was looking for. Now that I have my tapered modifier, I apply a bend modifier on top of it, and I bend it 180 degrees and along the y-axis. So this is how now my object looks like. So next I want to apply a twist modifier to it so that I could twist this object, and I would twist this object 360 degrees, and here's how my object would look like, or essentially the horn. So it kind of resembles a horn. Let me increase the sizes of the object. So let's make it 30 to 30, and so now here this object now looks more like a bullhorn. The final topic that I would talk about on this object is to modify the sizes of your object. So if you click on the object box and you increase its segment height from 1 to from 10 to 15, your end result will essentially look a lot more smooth. And by increasing this the height segments of the object, you essentially increase the quality of your result. Now you could even increase this line segments of this object from 1 to 5, and that would make the object a lot more smoother. Now notice that if you increase this length segments from 5 to 50, your object becomes smooth, but the changes in the smoothness from 5 to 50 isn't really that obvious. And of course, an object with 5 length segments is a lot less difficult to render, and it takes a lot less computation and rendering time than an object with the length segments of let's say 500. And as you can notice, when I'm changing the length segments, I really don't increase the quality of the image by much after about 4 or 5 or 6 length segments. Whereas for the height segments, an object with the height segments of 5 apparently does not look nearly as close and clear as an object with height segment of 15 and 25 and 50. And of course, an object with height segment of 50 looks a lot better than smaller objects. So now that I have a kind of neat look for my object, I can play with the object's size, height and width and so forth. So let's decrease the height of the object to about 100, and then let's modify the taper parameter so that you would get the appropriate result. And then the bend parameter doesn't change, and finally the twist parameter. And as you see, we have the object set up. Decrease the height, decrease the taper, and as you notice, I unclicked or unchecked the show end result icon, so I can see what the taper parameter applies and does to my object. And then I can apply the parameters all the way up to the bend and check all the way to the twist, and then I can again click back and toggle on the show end results, and then when I click on my objects, I'll see the end result shown. Okay, in 3D graphics and 3D design, you have 3 major operations: translation of objects from one location to another, rotation of the object, and scaling of the objects are basically your major transformations in 3D graphics, and in short, they are called transforms. So in your main toolbar of the 3ds Max, as I showed you last week and earlier today, you have select and move objects gizmo, and select and rotate object icon, and select and scale object. These 3 icons on the main menu bar, they allow you to apply transformations on your 3-dimensional objects in 3ds Max. So later on I'll show you how to apply these transformations in 2 different ways: to use the 3-dimensional gizmos like move and rotate and scale, or to type in your transforms. So as I showed you last week, when you apply the transforms, if you're doing a translation or a move gizmo, then you'll have the 3 axes placed on top of the object, and then you can either drag one axis to transform your object in one dimension, or drag 2 axes when they are both turned yellow, and then you can move your object in a plane. Same applies for your rotation. If you drag one of the rotation arcs back and forth or up and down, it would rotate your object along one axis. If you drag 2 at the same time, it rotates it along around a plane, and completely free rotation is when you apply it on the 3 rotation arcs at the same time. For the scaling operation, you can also scale either along one axis, along 2 axes, or along all the 3 axes, which will be a uniform scaling. You need to be careful when you're applying your uniform scale, non-uniform scale, when you're using the objects for animation, because when you scale your objects non-uniformly, that might mix up your animations. If you don't want to use the gizmos, as I showed you earlier, there is a transform type in area at the bottom of the screen that you could use and type in X, Y, and Z values within the X, Y, and Z fields. And when that when you apply that, if you're translating your object, it would move to X, Y, and Z position if you're applying an absolute transform type in, or it would apply it would move x and y and z units away from where it actually is if you apply it as an offset transform. Same for rotation and scale. So if you're in the absolute mode, the actual value will be applied on the rotation elements or the scale elements of the objects. If the offset mode is enabled, it would allow you to change the transform value by a certain amount relative to the current transform value. So for example, if your current transform value is for the rotation is 27 degrees along x direction, and if you apply 7 in the offset mode, it would rotate it 7 more degrees from its current location along the x, whereas if you apply 7 in the absolute mode, it would apply the entire it would rotate only it would rotate only 7 degrees along x direction instead of 37 plus 7. As we talked earlier last week, there are different coordinate systems, and the coordinate system is a way of tracking your objects in space. It is very essential that you learn about working with coordinate systems to create three-dimensional graphics. Your coordinate system is basically the tripod at the lower left of each viewport, and this tripod axis are locked to the world coordinate system, in which the xy plane is always the ground and the z axis always point up. So this is made so that you can orient yourself no matter where your objects are located and how they are rotated, and the size of the objects. Sometimes, especially when you're dealing with animation, it would be better and easier to work with object coordinate systems instead of the world coordinate system, because then applying frame by frame by frame movements and translations to your objects becomes a lot easier, especially if you have objects that are interacting. And so, for example, I'll show you a little later, you have a teapot and you want the teapot to pour in a glass. You'll see that, or a cup, you'll see that working with the object coordinate system makes it easier to coordinate your the interaction of the two objects, here the teapot and the cup. So reference coordinate systems are essentially the transformations that you could apply from the pull down menu on the main toolbar. By default, your reference coordinate system is view coordinate or view coordinate systems. You could have screen coordinate systems or world coordinate systems selected from your reference coordinate systems pull down. You can also have view coordinate system and local coordinate system. So let's see what these different coordinate systems are about. As I said earlier, the world coordinate system is the master reference for the location of all objects created in your three-dimensional scene. It's constant and you cannot change it. Everything is related to the world coordinate system eventually when your scene is being rendered. The axes are in a certain way, that is, your z always points up and x and y always point to the right horizontally and vertically, and the construction plane for this coordinate system is home grid, which is identical to xy, yz, and xz planes in the world coordinate system. Usually, when you're working with world coordinate system, you can have a sense and an understanding of how your objects are around the world and what is the limitations of the rotations and translations of objects in the world coordinate system. There's another coordinate system which is called the screen coordinate system, and in the screen coordinate system, the x-axis always points to the right of the screen and the y-axis always points toward the top of the screen. With the screen coordinate system, the xy plane is always parallel to the active viewport, and the z-axis always points out towards the viewport. That is, the screen coordinate system is as if you were looking in an orthographic view of the objects in the scene. The purpose of the screen coordinate system is to make it easy for you to move and rotate your objects primarily in orthographic viewports. However, you should note that working with a screen coordinate system in perspective view might mix up your intuitive senses about how you're viewing the scene, and it might be very difficult to get objects correlated and coordinated appropriate. As I said, the default coordinate system is the view coordinate system when it's selected, and the view coordinate system is a hybrid of the world and screen coordinate systems. In orthographic viewports, the screen coordinate system is used. In the perspective viewport, the world coordinate system is used if you are in the view coordinate system. This coordinate system is default, as I said, because it gives the best of both world and screen coordinate systems when you are working in the orthographic viewports, top, left, and front, as well as the perspective viewport when you're going back and forth. There's a particular kind of coordinate system that's called local coordinate system. Every object in the three-dimensional scene has its own individual coordinate system. It's called local coordinate system. In the local coordinate system, you're enabled to use transformation of an object relative to itself rather than relative to the world. This is absolutely essential when you're animating an object. For example, if there's a local coordinate system, it would be easier, and it is possible to create a character animation with realistic looking joint rotations. If you didn't have local coordinate system, it would be very, very, very difficult to coordinate all the joint movements, because then each of the joint movements, rotations, and transformations relative to a world coordinate system would require the understanding of all locations and orientations and scales of the joints and the body parts with respect to fixed coordinate system. And when your object in a whole would move, all of its body parts would be affected separately, essentially, and differently. So it would be very, very difficult to manage to do the animation within the world coordinate system. When you're transforming an object, a point of reference for the object is required. If you want to rotate your object, you need to have and specify a point around which you want to rotate the object along each of the axes. Same thing for scale and for moving the objects around. So the point of the transformation's reference point is called its pivot point. So for an object, you transform the object relative to its pivot point. So each and every object should have a single pivot point where is the origin of the object's local coordinate system. So as I said, the center or the origin of the world coordinate system is where the x, y, and z axes meet, which is on the xy plane, yz plane, and xz plane. For the object's local coordinate system, the pivot point is its origin for all the transformations. So it's really important for you to know where the pivot point of your objects are and how you can move and change your pivot points of the objects to be able to control the movements and transformations of your objects a lot more efficiently. So in the next set of exercises, I'll just go ahead and show simple transformations in objects, and then I'll show you the difference between the local coordinate system and using the pivot point to rotate an object and the world coordinate system and applying the global transformations, whereas local transformations in the two different coordinate systems. So let's go back to our 3ds Max and start up with this process. Okay, let me bring a teapot, essentially. Go to create, click on teapot, and then create a teapot in the perspective viewport. So my teapot has been created. Now I can apply, select, and move on the teapot. And how I can select and move? By pressing F4, I toggle the show faces. Now when my select and move gizmo is active, when I click on the object, I can move my mouse around X, Z, and Y axis, and when I move the mouse over the axis, the one that mouse is over is going to be active, and it turns yellow. And so I can move along X, along Y, and along z-axis. I can even move the objects within xy plane, as you see here. Within xz plane, notice the front viewport. My object is going up and down, and in the left viewport it just clearly shows me that it is moving along the xz plane. And if I click between the y and z, then my object would move along the y and z, and from the front viewport you can clearly see that the object is moving up and down along the y and z axis, whereas it's moving back and forth along the xz along the yz plane. Okay, now I can click on the rotate gizmo, and so my rotate gizmo is active. So if I move my mouse along the to rotate my object along the z-axis, you see that it tells me how many degrees it has rotated along the z, along the x-axis, and along the y-axis. I can rotate along y-axis at the same time, and along the xz-axis, and along the xy-axis and yz-axis. So the scale operation would let me scale either uniformly, as you see here, by dragging all the three axes, or dragging and scaling along xz-axis, essentially in the xz plane, in the xy plane, which is a shear transformation, or non-uniform transformation along just x, along just z, and along just y axis. Okay, let's remove this object, and let me just show you the coordinate systems, how the local coordinate systems work. So let's create a tube actually want to look like a cup, so that would be the cup that I created. And then let's create a teapot. And let's transform it on top of this. Okay, let's look at the top viewport, see if the teapot is essentially on top of the cup. Okay, so here we have the teapot and the cup, and we'd like to simulate the animation that shows us that the teapot is pouring tea in the cup. Now, from the main toolbar, if I click on select and rotate, and try to rotate the teapot along the z-axis. Okay, so before we do that, let's get a good look about the area, so that we'll have a good view of these two objects. And then, okay, my objects are selected. Now let's select and rotate the object, and let's click on the teapot, and you'll see that the reference point is the world coordinate system. And if you try to rotate this object, you see that it wouldn't really give you a good sense of pouring in the cup, and so it's kind of hard to come up with a rotation that allows you essentially animate. You see, it's very, very difficult to simulate. Okay, now let's press Ctrl Z until our object is essentially placed in a good in its original view. We need to select the local coordinate system for the teapot. So while your teapot is selected, click on the local coordinate system from the reference coordinate systems. As you can see, you have view, screen, world, parent, local, and so forth. So you click on the local coordinate system, and you notice that the rotate gizmo changes to indicate that now the coordinate system is your teapot's XY axis as opposed to the world coordinate system. Now you can drag your teapot along its Y axis, or along its Z axis, or along its X axis, and rotate and move your object. Now let's rotate the object along its Y axis. Now it looks like the object is more it can be controlled a lot better as opposed to the world coordinate system. There's just a issue here, and that is, although we're on the teapot's coordinate system and I'm rotating the teapot along its Y coordinate system, it seems that the center of the teapot is fixed and everything is rotating around the center, so the handle of the teapot is rotating. Whereas if I wanted to actually simulate and animate this teapot pouring into the cup, I wanted the handle of the teapot to be fixed and for the object to rotate along the handle. So in order to do this, you could essentially change the pivot point of your object and place it anywhere else other than its center of gravity. So you can move your object and rotate your objects with respect to another point on their coordinate system, local coordinate system. To do so, you need to click on Hierarchy and then click on the Effect Pivot Point. When you click on the Effect Pivot Point, you'll see that the pivot point changes, and you can now move your pivot point essentially by moving it along this X, Y, and Z coordinate systems. So you need to move your pivot point around where its handle is, and now my pivot point is placed on the handle of the object. Let's check on the top viewport and make sure that on the top viewport it is on the handle, and same with the left viewport and the front viewport. Now let's go back to the perspective viewport. And let's move our object a little bit upper. And now you can rotate your object and along its Y axis. Oops. And here you see that your movement becomes a lot more realistic. So if you rotate now along the y-axis, you see that now this animation gives a much more realistic way of moving the objects within their own local coordinate systems. Alright, so with pivot point and local coordinate systems, I would like to close the lecture for this week, and I'll post everything online on the Blackboard, and we will continue with working with the basics of Autodesk 3ds Max next week, and then we'll delve into more detailed 3D modeling, and we continue our work with trying to essentially create artistic objects and materials and tools in the 3ds Max. Thank you, and I will talk to you next week.